you're human number 108 billion. Not approximately, not as a rough estimate. As a best current calculation of how many human beings have been born on this planet since the first of our species drew breath, you are somewhere in that vicinity. One of 108 billion people who have lived, thought, wondered, and eventually stopped. That number feels large. It isn't. In 1983, a British physicist and mathematician named Brandon Carter was thinking about a problem that sounds almost trivially simple. If you don't know how many humans will ever exist, if the total number is unknown, the future unwritten, can your position in the sequence tell you anything about where the sequence ends? You are number 108 billion. Are you near the beginning, the middle, the end? Carter applied a principle so basic it's almost embarrassing. The same principle that tells you, when you join a queue without knowing its length, that you're probably not at the very front or the very back. That you're probably, statistically, boringly, reliably, somewhere in the middle. The math resolved, and when it did, the answer was not comfortable. If you're probably somewhere near the middle of the full sequence of humans who will ever live, if the Copernican instinct that we are not specially positioned applies here as it applies everywhere else, then the total number of humans who will ever exist is probably around twice the number who have existed so far. Roughly 200 billion people in total. At current population levels and projected growth, 200 billion humans means humanity has somewhere between a few centuries and a few thousand years remaining. Not millions. Not the vast open future we tend to assume is waiting for us. Centuries. The math doesn't specify a cause, doesn't name a catastrophe, doesn't require a war or a plague or a climate tipping point or a misaligned AI. It only requires that you're not special, that your position in the human sequence is probably typical, that the same statistical humility we apply to everything else in the universe applies uncomfortably to us. If these explorations intrigue you, a like or subscribe helps, but let's continue. The argument has a name, the Doomsday Argument. And in the 40 years since Carter first sketched it out, in the decades of papers and counterpapers and philosophical debate that followed, something remarkable has happened. Nobody has cleanly refuted it, not for lack of trying. Some of the most rigorous analytical philosophers alive have taken the Doomsday Argument apart, examined every joint, tested every assumption. Some have concluded it fails, others have concluded it holds. The debate continues at the highest levels of philosophy and probability theory. What nobody has done is make it go away. It sits there, patient, statistically implacable, waiting for an objection that holds up all the way down. So let's understand exactly what we're dealing with. Let's follow the argument to its foundation, not to frighten ourselves, but because an idea this consequential, this difficult to dismiss, deserves to be understood completely. Starting with the deceptively simple logic at its core. Imagine an urn. You can't see inside it. You don't know how many marbles it contains. All you know is that each marble is numbered sequentially. 1, 2, 3, starting from the first marble placed in the urn and going up to whatever the total happens to be. Someone reaches in and hands you a marble without looking. It says 108 billion. Now. What's your best guess about how many marbles are in the urn? The answer, using straightforward probability, is this. If you had drawn a marble from an urn containing 1 trillion marbles, the odds of pulling number 108 billion are vanishingly small. You'd be drawing from the bottom 0.01% of the sequence. Possible, but deeply improbable. If the urn contains 200 billion marbles, your draw makes much more sense. You're in the middle. A typical draw. Exactly what probability would predict. The math says your marbles number is probably somewhere near the middle of the full sequence, not at the very beginning, not at the very end. Somewhere typical. This is called the Copernican principle, the idea that you're probably not specially positioned. Not the first, not the last, not the outlier. the same reasoning that displaced Earth from the centre of the universe, the same reasoning that placed our Sun as an ordinary star in an ordinary galaxy, applied now to the sequence of human beings. You are marble, number 108 billion. The urn probably contains around 200 billion marbles total. Now replace the urn with human history. Each marble is a human life, numbered in order of birth. You're somewhere around number 108 billion. The Doomsday Argument says, by the same logic as the marble, that you're probably near the middle of the full sequence of humans who will ever live, which means the total sequence is probably around twice what it's been so far. Roughly 200 billion human lives in total. Now, do the population math. Earth currently supports around 8 billion people. Population. Projections suggest we'll peak somewhere between 10 and 12 billion before stabilizing or declining. At those levels, to produce another 100 billion humans, the second half of the sequence, you need roughly 750 to 1,000 years of continued civilization. Maybe a little more, maybe significantly less, but not millions of years. Not the vast, open-ended future we tend to assume is ours. The Doomsday Argument's 95% confidence interval, the range within which human extinction probably falls, runs from a few centuries to a few thousand years. On a cosmic timescale, that's tomorrow. Let's make the logic even more precise. There's a specific formulation called the DA, the Doomsday Argument proper, developed by philosopher John Leslie in the 1990s, building on Carter's original insight. It works like this. Suppose two theories about the future are equally plausible going in. Theory A says humanity survives for millions of years and produces trillions of future humans. Theory B says humanity ends within a few centuries and your generation is among the last. Before any calculation, you might assign each theory a 50% probability. Seems reasonable. But now add one piece of information. You exist right now as human number 108 billion. Under Theory A, the long future, the probability of being born this early in the sequence is tiny. If trillions of humans are coming, being among the first 108 billion is like drawing the lowest numbers from an enormous urn. Improbable. Under Theory B, the near-term end, being born right now makes perfect sense. You're near the middle of a short sequence, exactly where probability puts you. The observation of your own birth position is strong evidence for Theory B over Theory A. Not certainty, not inevitability, but significant mathematically defensible evidence that the short future is more likely than the long one. The Doomsday Argument doesn't predict the cause of extinction. It doesn't name a mechanism. It simply says, given where you sit in the sequence, a short future is more probable than a long one, and the calculation is hard to argue with. Here's an analogy that makes the stakes concrete. You wake up in an unfamiliar building. You don't know if it has 10 rooms or 10,000. You're in room number 7. What's your best guess about the building's size? Probably somewhere around 14 rooms, because if the building had 10,000 rooms, finding yourself in room 7 would be extraordinary luck, or extraordinary bad luck, depending on how you look at it. You'd be in the bottom 0.07% of the sequence. Possible, but not what probability predicts. Now, you're in room 7 of human history. The building has housed 108 billion lives. How many rooms does it have? The argument is almost insultingly simple. That's what makes it so difficult to dismiss. There's no exotic physics here, no speculative technology, no assumption about alien civilizations or climate tipping points or political failure. Just probability theory, the same mathematics that underlies insurance tables, medical trials, and weather forecasting, applied to the one variable nobody wants to treat as a variable: how many more of us there will be. And here's what makes the Doomsday Argument different from ordinary existential risk calculations. Most arguments about human extinction start with causes. They say, nuclear war could end us, therefore we should worry about nuclear war. Or, misaligned AI could end us, therefore we should worry about AI. The risk is downstream of the mechanism. The Doomsday Argument runs the other direction. It doesn't need a cause. It starts with your position in the sequence and works backward to the conclusion that the sequence is probably shorter than we assume. Whatever mechanism ends us, whatever cause fills in the blank, the statistical argument suggests an ending is probably closer than our optimism tends to allow. It's not predicting how we end, it's predicting roughly when. And it's doing it with nothing but a number and a principle, so basic we use it to understand everything else in the universe. So why hasn't anyone refuted it? Not for lack of trying. The Doomsday Argument has been attacked from almost every direction imaginable, by philosophers, mathematicians, probability theorists, physicists. Each attack has found something, some loose joint in the reasoning, some assumption that could be questioned, and each time the argument survives, not untouched, not perfectly intact, but standing. And the attempts to bring it down have revealed something almost more troubling than the argument itself, that the objections are harder than they look. Let's try to break it, because that's the honest thing to do with an argument this consequential, not accept it, not dismiss it. Take it apart systematically, the way you test a bridge before crossing it, and see what holds. The objections are real. They've been made by serious people, and each one, when you follow it all the way down, does something unexpected. It doesn't destroy the argument, it relocates the problem. The first objection: we could have billions of descendants. Maybe humanity expands. Off-world colonies, generations spreading across star systems, trillions of future humans living lives we can't currently imagine. In that scenario, being born at number 108 billion doesn't put you near the middle of the sequence. It puts you near the very beginning. The argument collapses. We're early, not late. This is the most intuitive objection, and it sounds, at first, like it works. Here's the problem. The Doomsday Argument already accounts for this possibility. It doesn't say a long future is impossible. It says a long future makes your current position deeply improbable. If 1 trillion humans are coming, the odds of being born right now, in the first 108 billion, are less than 0.01%. You'd be in the extreme early tail of the distribution. Not impossible, but requiring an explanation. Why are you, specifically, one of the extraordinarily rare early humans? What makes your position in the sequence special enough to justify that improbability? The Copernican principle says, probably nothing. You're probably not special. Which means the long future scenario, while possible, requires you to be extraordinarily lucky in a very specific and uncomfortable way. The objection doesn't defeat the argument. It just asks you to bet on being exceptional. The second objection: the argument ignores future technology. Medicine, genetic engineering, life extension. Maybe future humans live for thousands of years. In that case, even a short timeline produces an enormous number of human life years. The total count of individual humans could be modest, while the total human experience is vast. This is clever, and it genuinely complicates the math, but notice what it requires. It requires that population stays relatively flat while lifespans extend dramatically. It requires that the number of individual humans, not human years, but individual people, stays low enough that 108 billion remains a meaningful middle position. In other words, it requires a very specific kind of future that is itself uncertain. And even in that future, the argument doesn't disappear. It shifts. You'd need to recalculate using human life years rather than human lives. The math gets messier, the conclusion gets softer, but it doesn't go away. The third objection, and the most philosophically serious, is about reference classes. This is where the debate among actual philosophers lives. The Doomsday Argument assumes you should reason as if you're a randomly selected member of the set of all humans who will ever live. But why that reference class? Why not all conscious beings? All mammals? All information processing systems? If your reference class is all conscious beings, including whatever artificial intelligence might exist in the future, then 108 billion humans is a tiny fraction of the total observers and your position tells you almost nothing about when humanity ends. This objection has a name, the self-indication assumption. The idea that the very fact of your existence is evidence that you're in a large reference class, that conscious observers are common, that the future is long, that the universe is full of minds. Against this sits the self-sampling assumption, the foundation of the Doomsday Argument, which says you should reason as if randomly selected from your specific reference class. Humans. Not all possible minds, not all conscious beings. The debate between these two positions is genuine. Philosophers have not resolved it. Brilliant people sit on both sides. But here's what's uncomfortable about using the self-indication assumption to escape the Doomsday Argument. It requires that observers like us are common, that the universe is teeming with conscious minds, that intelligent life is abundant, and yet the universe appears silent. The Fermi paradox suggests observers are not common, that something prevents them from proliferating, that the long, observer-rich future required to make the self-indication assumption work is precisely the future that the evidence from astronomy makes least plausible. The escape route from the Doomsday Argument runs directly into the Fermi silence. You can take it, but you don't end up somewhere comfortable. The fourth objection is the most personal. Someone has to be born at every point in the sequence. Someone is number 1. Someone is number 108 billion. Someone will be the last. None of these positions are inherently more or less probable for the person occupying them. They're all just positions. Why should being number 108 billion tell me anything? This objection feels intuitively powerful, and it contains something real. But it confuses two different questions. The question isn't whether it's surprising that someone is born at position 108 billion. Of course someone has to be. The question is what you should infer from the fact that you are that someone, given that you don't know the total sequence length. Think back to the marble. Of course, some marble has to say 108 billion, but if you draw it, if that's your marble, you still use its number to estimate the urn's size. The fact that someone had to draw it doesn't change what you should conclude from having drawn it. The objection dissolves under examination. And so, we arrive at the uncomfortable position that the philosophical community has occupied for 40 years. The Doomsday Argument is probably wrong. Most researchers who have studied it carefully believe there's an error somewhere, an assumption that doesn't hold, a reference class that's been wrongly specified, a place where the marble analogy breaks down when applied to human lives. But nobody has found it cleanly enough, argued it convincingly enough to close the debate. The argument survives not because it's certainly right, it survives because it's resilient. Every exit leads somewhere harder. Every objection either fails or relocates the problem to a different domain, where a different uncomfortable question is waiting. And there's one domain where it relocates most dramatically. One place where the Doomsday Argument doesn't just survive the objections, it finds unexpected support from a completely different direction. From the silence. From the same void we've been staring into every time we point a radio telescope at the sky and hear nothing back. Because if you apply the Doomsday Argument not just to humanity but to every civilization that has ever developed intelligence, the math produces a result that the Fermi paradox and the Doomsday Argument have been circling independently for decades without fully meeting, until now. Here is something that doesn't get discussed enough. The Doomsday Argument and the Fermi paradox were developed independently. Different researchers, different frameworks, different questions entirely. One is asking, where do we sit in the human sequence? The other is asking, where is everyone else? They arrive from completely different directions at the same place. Apply the Doomsday Argument universally, not just to humanity, to every civilization that has ever developed intelligence anywhere in the universe. Every species that looked up at the sky, built tools, asked questions, reached the point of being able to reason about its own position in time. Each of those civilizations, if the argument holds, would find itself in the same position we're in, somewhere near the middle of its own sequence, probably not in the first fraction of its history, probably not near some vast open-ended future, probably somewhere typical, somewhere that suggests the full sequence is roughly twice what it's been so far, which means every civilization, at the point where it becomes capable of asking this question, is probably also near the point where the question stops being hypothetical. Think about what that implies for the sky. We've been searching for signals from other civilizations for decades. This silence has produced dozens of explanations. Maybe they're too far away. Maybe they're not broadcasting. Maybe they're using communication methods we haven't discovered yet. The Doomsday Argument offers a different explanation. Maybe we don't hear them because they're gone, not because they destroyed themselves before reaching the broadcasting phase, though that's possible too, but because the window between developing intelligence and approaching the end of the sequence is narrow for everyone, because any civilization capable of sending a signal we could detect is, by the same statistical logic, probably near the end of its signal sending period. The sky isn't silent because civilizations never develop. It might be silent because they don't last, and the Doomsday Argument applied universally suggests that not lasting is the statistically expected outcome, not the exception. This is where the two arguments become something more than the sum of their parts. The Fermi paradox asks, where is everyone? The Doomsday Argument answers, probably where we're going, not destroyed by any specific catastrophe, not prevented from arising by some improbable filter in the early steps of evolution, but concluded, finished, having run their sequence to its statistical midpoint and then, by whatever mechanism, not continuing. The great filter, the wall that civilizations apparently don't pass, stops being mysterious when you combine these two frameworks. It's not a wall, it's a distribution. Every civilization has a sequence. Every sequence has a midpoint. Every civilization that reaches the midpoint is, by definition, probably near it. And the midpoint, for a civilization that develops intelligence and then faces the compounding risks of its own capability, is apparently not very far from the beginning. There's a researcher named J. Richard Gott who took this logic and made it quantitative in a way that's hard to dismiss. In 1993, Gott was visiting the Berlin Wall, not during its construction, not during its fall, just a random visit at a random point in its existence. He asked, given that I'm observing this wall at a random point in its lifetime, what can I predict about how much longer it will stand? The math said, probably not much longer than it's already stood. The wall had been standing for 28 years when Gott visited. His calculation predicted it would stand for between 2.4 and 630 more years, with 95% confidence. It fell 8 years later. Gott then applied the same logic to humanity. Our species has existed for roughly 200,000 years. The calculation predicts we'll survive for between another 5,100 years and 7.8 million years, with 95% confidence. That sounds reassuring until you notice the lower bound. 5,100 years. On a cosmic timescale, that's not a future, that's a rounding error. Now here's the convergence that matters. Gott's calculation, Carter's argument, the Fermi silence, the self-destruction hypothesis we explored in our last video. These are not the same argument. They come from different disciplines, use different methods, make different assumptions, but they keep pointing at the same region of the timeline, not millions of years, not the vast star-spanning future our optimism reaches for, centuries to thousands of years, a future that is real and meaningful on a human scale, long enough to matter, short enough to be urgent, but radically shorter than the default assumption most people carry without examining it. The default assumption is worth naming. Most people, when they imagine the future of humanity, imagine something essentially unbounded. Centuries blending into millennia, blending into some distant, unimaginable future, where our descendants are so different from us they barely qualify as human. A future so vast it absorbs every present failure, every current crisis, every near miss, because there's always more time. The Doomsday Argument says, examine that assumption, not with despair, not with certainty, with the same statistical humility we apply to everything else we want to understand clearly. Your marble number 108 billion. The urn is probably not infinite. And if the urn isn't infinite, if the future is genuinely shorter than we assume, then something follows. Something about how we should think about this century specifically, about the decisions being made right now, about what it means to be alive at a point the math suggests is probably not early in the story. But before we get there, there's one escape hatch we haven't tried yet. One exit from the argument that doesn't require refuting the probability theory. It requires something stranger. It requires questioning whether the urn, the sequence of human lives, is the right container to be reasoning about at all. Here is the one escape hatch that actually works. Logically, mathematically, cleanly, if you can take it. The Doomsday Argument rests on a single foundation, that you're a randomly selected member of the sequence of all humans who will ever live, that your position, number 108 billion, is a typical draw from the full distribution. But what if the sequence isn't what we think it is? What if the humans living inside a simulated reality, running on computational substrate, their experiences fully real to them but generated rather than biological, vastly outnumber the humans who ever lived in base reality? In that case, the reference class explodes. Not 200 billion humans total, not even a trillion, but an effectively uncountable number of simulated humans running across thousands of simulated histories in thousands of simulated civilizations, across whatever timescale the civilization running the simulation chooses to allow. In that reference class, being born at position 108 billion doesn't put you near the middle of the sequence. It puts you near the very beginning. The Doomsday Argument dissolves. This isn't a new observation. Philosophers working on both the simulation hypothesis and the Doomsday Argument have noted the intersection for years. If we're simulated, if Nick Bostrom's trilemma resolves in the direction of us being inside a constructed reality, then the statistical foundation of the Doomsday Argument collapses. The marble analogy breaks down because the urn isn't the one we thought we were drawing from. We're not drawing from the urn of biological humans on a single planet. We're drawing from the urn of all observers in all simulations ever run. And that urn is so large that our position tells us almost nothing about when our specific simulation ends. Take a breath. Because here's where it gets strange. The simulation hypothesis doesn't rescue us from the Doomsday Argument. It trades one existential problem for another. Because if we are simulated, if the reason the Doomsday Argument fails is that we're inside a constructed reality being run by a more advanced civilization, then the question of when humanity ends stops being a statistical one. It becomes a question of intention. The simulation doesn't end because of nuclear war or climate collapse or misaligned AI. It ends when whoever is running it decides to turn it off, which could be tomorrow, which could have already been decided. Which is not a question any amount of careful reasoning on our part can answer, because the answer exists entirely outside the reality we have access to. The Doomsday Argument tells you the sequence is probably short. The simulation hypothesis tells you the sequence length isn't even yours to calculate. Both conclusions lead to the same place. Uncertainty about the future so fundamental it can't be resolved from inside the frame we're standing in. And there's one more wrinkle. The simulation hypothesis, if true, doesn't eliminate the doomsday logic entirely. It relocates it. The civilization running the simulation, the base reality humans who built the substrate we're running on, they have their own sequence, their own position in their own distribution, their own marble with their own number, and for them, the Doomsday Argument applies in full. If they end, if the base civilization hits its own filter, its own critical window, its own point of maximum capability and minimum wisdom, the simulation ends with them. We don't escape the argument by being simulated, we just inherit it from one level up. every exit leads somewhere harder. That's the Doomsday Argument's most persistent feature. Not that it's certainly correct, but that it's extraordinarily difficult to leave without taking something uncomfortable with you. Which means the most honest response isn't to find the exit, it's to ask what it means to live, fully inside the argument. What it means to be number 108 billion, in a sequence that is probably finite, on a planet that is definitely fragile, in a century that is, by every framework we've examined tonight, probably not early in the story. That's where we're going next. Let's set the math aside for a moment, not because it stops being true, but because there's a point where the numbers have done their work and what remains is a human question. You're probably not early, not in the vast, comfortable sense we tend to assume, not in the sense that allows existential risk to feel distant, someone else's problem, some future century's burden, something that the sheer length of the road ahead will eventually absorb. The Doomsday Argument says, the road is probably not that long, and that changes something, not everything, but something. The first change is in how we read this century. Most of human history has been able to treat its own moment as somewhere in the middle of an open story. Civilizations rose and fell, but the human project continued. There was always a next chapter, a recovery, a rebuilding. The assumption of continuity was so reliable, it barely registered as an assumption. We are probably the first civilization that cannot make that assumption cleanly, not because we're uniquely pessimistic, not because we lack the resilience of our ancestors, but because for the first time we have built things that could actually end the story, not pause it, not damage it severely, end it. And we've built them fast enough that the wisdom required to manage them is genuinely struggling to keep up. The Doomsday Argument doesn't cause that situation. It just gives it a statistical frame, a frame that says, this isn't paranoia, the math agrees with the concern. The second change is subtler. There's a version of existential risk thinking that produces paralysis. That looks at the scale of the problem, the coordination failures, the recursive traps, the compounding threats, and concludes that individual action is meaningless, that the forces in play are too large, the incentives too entrenched, the window too narrow for anything any single person does to matter. The Doomsday Argument taken seriously points the other way, because if the sequence is probably short, if this century is probably one of the last in which the outcome remains undetermined, then the decisions being made right now carry a weight that no previous generation's decisions have carried. Not because earlier generations didn't matter, but because they were making decisions inside a system with more margin for error, more time to correct mistakes, more future to absorb the consequences of getting things wrong. We have less of that buffer than they did, which means the decisions made now, in the labs, in the legislatures, in the values we choose to embed in the technologies we're building, are decisions being made closer to the final accounting than any previous generation realized they were making. That's not paralyzing. That's clarifying. There's a word philosophers use for this kind of thinking. Moral urgency, not panic, not despair. A specific sharpening of attention that comes from genuinely internalizing what's at stake, from letting the numbers land rather than holding them at a comfortable theoretical distance. The people who have sat with the Doomsday Argument long enough to feel its weight, not just understand it intellectually, but feel it, tend to emerge with a particular quality of attention. They stop treating the long-term future as a given. They start treating it as something that has to be chosen, built, defended against the very real possibility that it doesn't arrive automatically. And here's what that means practically. It doesn't mean abandoning ordinary life. It doesn't mean every conversation needs to be about existential risk or every decision evaluated against civilizational stakes. It means something quieter. A background awareness that the window is open, that the margin is smaller than optimism suggests, that the people working on the hard problems, alignment, coordination, long-term institutional thinking, WEM, are working on something that the math says actually matters at the scale they believe it does. The Doomsday Argument, in the end, is not a prophecy. It's a prior, a statistical starting point that says, don't assume the future is infinite. Don't treat continuity as the default. Don't postpone the hard choices on the assumption that there will always be more time. There might be. But the math says probably not as much as you think. And that, more than the specific calculation, more than the confidence intervals or the reference class debates, is what the argument is actually for. Not to frighten, to orient, to hand you, carefully, the same awareness that the numbers produce when you follow them honestly, and trust you to do something useful with it. Because the argument has two readings, and which one turns out to be true depends entirely on what happens next. Here is what the Doomsday Argument cannot tell us. Which reading is correct? It cannot tell us whether we are near the end of a short story, one of the last generations living in the narrowing final chapters of the human sequence, or whether we are early enough that the story still has room to become something vast and extraordinary. The math establishes the probability. It doesn't determine the outcome, and that distinction is everything. Because probability is not fate. The marble drawn from the urn tells you something about the urn's likely size. It doesn't seal the urn. It doesn't fix the number of marbles remaining. It doesn't prevent someone from reaching in and adding more. The Doomsday Argument is a reading of where we probably are. It is not a sentence on where we have to end up. And here is the thing that the argument, for all its cold mathematical authority, cannot calculate. What a civilization does when it knows. We have something that no marble has, no numbered ball drawn from an urn, no randomly selected observer in a passive distribution. We have awareness, the capacity to look at the sequence, understand our position in it, feel the weight of the probability, and choose, with that weight fully present, what to do next. The Doomsday Argument was designed to be a statistical observation. It functions, if you let it, as something more useful, a call to attention, a reminder that the future is not a given, that continuity is not guaranteed, that the assumption of infinite time ahead, the comfortable background assumption that allows urgency to always be deferred, is probably not supported by the numbers, and that the people alive right now in this decade making decisions about the technologies and the institutions and the values that will shape what comes next are probably not early, which means what they do probably matters more than they realize. Two readings, we are near the end, and the silence of the universe is the confirmation, the final data point in an argument that has been true for every civilization that ever reached this question. Or we are early enough, aware enough, warned enough, equipped enough, that this particular civilization writes a different ending, becomes the exception that the math said was improbable, but never said was impossible. The argument cannot tell us which. Only the future can, and the future, for perhaps the first time in the history of intelligence on this planet, is genuinely, consequentially, urgently being decided, right now, by us. We're night space. If tonight left you with something you'll carry, a question you didn't have before, a weight that clarifies rather than paralyzes, a reason to take seriously what this moment actually is, then it did what it was built to do. If you want to keep sitting with the questions that don't have clean answers, the ones at the edge of what we know about, time, probability, consciousness, and what we owe to futures we can't see, subscribe. We'll be here, the sequence continues, for now.